Alright, so we have seen how we can say if a set of objects is a vector space. Now we will come to an important concept related to a vector space, that is the basis of a vector space. Basis of a space. Okay. So what is the basis of a vector space? Well, it is simple. Um, a basis of a vector space is a set of vectors. A basis is a set of vectors that we can use to construct the entire vector space. All right. Vectors, well, to be more accurate, we should say the set of all independent vectors. The set of all independent vectors that can construct the vector space. So what do we mean by that? All right, by that we mean again we return to one of our examples. Suppose we consider the set of all 2 by 1 matrices. The set of all 2 by 1 matrices like this, A, B. This consists of 2 rows and 1 column. So we will call a set a basis. A basis for this set. A basis for this set will be a set of vectors that we can use to make any of these matrices by a linear combination. Okay, we can add another part to this definition: by linear combination. One example of a basis set for the set of all 2 by 1 matrices is the set 1 0 and 0 1. Okay, we can use this set, we can use these 2 vectors to make any vector in this set. How? For example, suppose I want to make the vector 5 9. Okay, can I make this vector using these two, using a linear combination of these 2 vectors? Yes, I can write 1 0 0 1. I can write 5 here and I can write 9 here. Okay, so 5 times this first vector plus 9 times this second vector is equal to this vector. And well, you can see that this can be generalized quite easily. If I want to make any vector of the form a b, then I can simply write a times 1 0 and b times 0 1 to make this vector. So if we have a set of independent vectors like this that can be used to make any vector of our set, then we will call this set a basis set. Okay, this will be called a basis set. Okay, so this actually, the basis set for a vector space is not unique. We can have many basis sets. All right. So, for example, this set is one of the basis sets of the set of all 2 by 1 matrices. We can actually have another basis set. Suppose I have the basis set like this, 0, 1, and I have the set 1, 1. We can actually form any 2 by 1 column matrix using these two vectors. Okay, so suppose I want to make the vector 5, 4 using these two vectors. If you see that if I multiply the first vector by -1, 0, 1, and if I multiply the second vector by 5 times 1, 1, then the result will actually be 5, 4. And it can be easily shown that we can make any vector of the form a, b using these two vectors. So the set of the basis set of a vector space is not unique. We can actually have many sets, perhaps even infinite number of sets, infinite number of basis sets that we can use to construct a vector space. One thing to notice is that these sets need to be independent. All right. We will call a basis set. We will call a set a basis set if the vectors in that set are independent. What do we mean by independent? We mean that we cannot make one vector of that set using another vector. Suppose I want to say that, well, can I make, okay, independent vectors. All right. So independent vectors. Well, again we will work with an example. So can I make the vector 2, 0 using the vector 1, 0? Well, yes, I can. If I add 1, 0 to it 2 times, then I can get 2, 0. Or if I multiply 1, 0 by the number 2, then, well, we will get 2, 0. So the set 2, 0 and 1, 0 is not an independent set. All right, we can express one vector using another. Is the set can we make 1, 0 using the vector 1, 1? Well, you can try, but you will soon see that we actually can't do that. Okay, we can't do that. So we tell that this set is an independent set. 1, 0 and 1, 1 is an independent set. So for a set to be a basis set, all the vectors in that set need to be independent. Okay, so this is an independent set, and this is not an independent set. We can call this a dependent set.